Hi dear students, in this video we are going to learn about charge to mass ratio of electron. Charge to mass ratio, which is known as E by M ratio of electron, which is also known as specific charge, For the first time, the charge to mass ratio of electron has been calculated by J.J. Thomson. J.J. Thomson has calculated the charge to mass ratio of electron. Experimental setup will be similar to that of the cathode rays discovery, right? A cylindrical hard glass tube is taken, which is known as CRT, right? And this is the one end, it is coated with the zinc sulfide screen. This is coated with the zinc sulfide, fluorescent material. And this is filled with some gas, and connected with the vacuum pump. Here the pressure inside this glass tube is 0.001 mmHg, right? So 0.001 mmHg, and two metal plates are fitted. One is cathode, other one is anode. The metal plate which is connected with the negative terminal of the battery is called as a cathode. This is cathode, this is a negative terminal of the battery, this is a positive terminal of the battery, and these are connected like this, right? Here the pressure, I am writing it as a 0.001 mmHg here, right? So then cathode rays are hitting the zinc sulfide screen. If there is some hole is present on the anode, then it is hitting at a point B. Zinc sulfide screen, it is hitting at a point B, right? Then alone that electric field is applied. We know cathode rays will deviate in external electric as well as magnetic fields, right? So alone electric field is applied. Assume this is a positive plate, this is a negative plate, right? So then cathode rays is hitting at a point A. Okay, students, when there is no field, cathode rays are hitting the zinc sulfide screen at the point B. When alone electric field is applied, then it is hitting at a point A. When the magnetic field alone it is applied, then that is hitting at a point C. This is a magnetic field is applied. Assume this is a south pole, this is a north pole. Then the cathode rays are hitting at the point C, right? Alone magnetic field is applied, then cathode rays are hitting zinc sulfide screen at the point C. Alone electric field is applied, then the cathode rays are hitting at the point A. When there is no field, then the cathode rays are hitting the zinc sulfide screen at the point B, right? Then what he has done is he has applied both the fields, electric field as well as a magnetic field, simultaneously, such that they are perpendicular to each other. Both are perpendicular to path of the cathode rays, right? Like this, two metal plates are kept, that is charged plates, and the magnetic field is opposite to that is a perpendicular. Then he adjusted the field strengths the magnetic and electric fields such that when both are applied simultaneously, the cathode rays are hitting the zinc sulfide screen at B, point B, where that is cathode rays are hitting at point B when there is no field, right? When there is no absence of electric and magnetic field, the cathode rays are hitting the zinc sulfide screen at point B. Then after applying both the fields perpendicular to each other, he adjusted the field strength such that the cathode rays are hitting again at the point B, like that he adjusted. So, and by equating that field strength, he has calculated E by M value of electron, right? In absence of both magnetic and electric fields, cathode ray hitting the zinc sulfide screen at point B when electric field alone applied, cathode ray hitting the zinc sulfide screen at point A when alone magnetic field is applied. Cathode rays are hitting at point C. Then he applied both the fields simultaneously. He applied both the fields simultaneously and adjusted the field strengths such that cathode rays hitting zinc sulfide screen at point B, right? So again, that cathode rays are hitting the zinc sulfide screen at a point B where there is no field. When there is no field also, the cathode rays are hitting at point B. When alone electric field is applied, then cathode rays are hitting the zinc sulfide screen at a point A. Alone magnetic field is applied, then cathode rays are hitting the zinc sulfide screen at a point C. And both the fields are applied simultaneously perpendicular to each other. Then he adjusted the field strengths of electric and magnetic such that the cathode ray is hitting at a point B. And then by equating that magnetic field strength and electric field strength, he has calculated E by M value. Students, by equating magnetic field strength and electric field strength, because these values are known, right? Field strength, he calculated E by M value, that is a charge to mass ratio of electron. E by M value of electron is 1.7588 into 10 power 11 coulomb per kilogram, right? which is also known as specific charge, which is also known as specific charge. And RA millican calculated the charge on electron from his famous oil drop experiment, and in observation he told that the charge on oil drop is integral multiple of E, that is E value is 1.602 into 10 power minus 19 coulombs. That is same as the charge on the electron. Okay, total charge Q is equal to, it is the integral multiple of the some charge E, right, where n value is a positive integer, n is equal to 1, 2, 3, 4 and so on like that, right. So the charge on the electron has been calculated by R.A. Millikan by using his famous oil drop experiment, and one of his observation that the charge on oil drop is integral multiple of the some value E, that is same as the charge on the electron. E is equal to 1.602 into 10 power minus 19 coulombs, right. So generally the relative charge for the electron we will take it as a minus 1.602 into 10 power minus 19, right. So if you do E by M value, then E will get cancelled, we will get a mass of electron, right, which is same as mass of electron is equal to E value is 1.602 into 10 power minus 19 coulombs, right, and E by M value is Thomson calculated E by M value, that is 1.7588 into 10 power 11 coulomb per kilogram, right. For the charge unit is coulombs. Then on simplifying this, the mass of the electron is 9.1 into 10 power minus 31 kilogram, right. Students, this is about the charge to mass ratio of electron and how the R.A. Millikan has calculated the charge on electron from his oil drop experiment, and the mass of the electron, that is E by M, right. Thanks for watching.